Welcome, class. I'm going to tell you the first great story, first great lesson, the origins of the universe and the earth. Well, since the very beginning, people have been aware of the earth that we live on and the natural forces that come with it. They could feel nature even though it's hard to define. And there's certain things that people do when there's a question that's really hard to answer. One thing people do is they ask the smartest people around, they say, where did this earth that we live on come from? Like, what is nature? What does it do? And the wise people might say, well, nature is responsible for everything that ever happened, and all things in nature obey certain laws or rules, and the whole universe has an order. And we don't understand all the details of that order, but we're learning more and more all the time. Many people have thought this was hard to believe. How could that be possible? How could the stars twinkling overhead and the sea's rolling waves and the sun and the mountains and the wind, how could they have all been made by natural processes? So people made up stories like folk tales and myths and stories that involved people and animals who helped create the earth, and they thought that since they couldn't explain how the birds and fishes and trees and flowers were made, well, there must be some kind of magic involved. And it really is awesome. Do all things really obey certain rules? Can animals and plants and rocks really follow rules? Can they really obey laws? Well, we can see that certain animals understand when you talk to them, like a dog, for example. Yeah, like a dog can learn a little bit of human language, so they'll even come over when we call their name. But the winds and the sea and the mountains, you can shout and scream and wave your arms all you want, but they can't hear you because they're not even alive. They certainly won't obey you unless you command them to do something they're already doing, like stand where you are in silence. Yeah, that's how it seems to us. But as you'll see, everything that exists, whether it's alive or not, in all that it does, and by the very fact of its being there, actually obeys the laws of nature. Can particles on and from the earth know that they're obeying laws of nature? Well, it's hard to say. Those that are inanimate just go on existing. Those that are alive move and go on living, yet every time a cool wind brushes your cheek, it's evidence of obedience. It's almost like the air has a voice. And if we could hear it, it might be saying, I obey. And when the sun rises in the morning and colors the glittering sea, it's almost like the sun and the sunbeams are whispering, I obey. When you see a bird on the wing, or fruit falling from a tree, or a butterfly hovering over a flower, the birds on their flight, the tree and the fruit and its fall to the ground, the butterfly and the flower and its fragrance, are all saying the same words. They say, I hear, I obey. Most scientists, and most people in general, think that in the very beginning, everything in the whole universe was packed into a space that was infinitely small. Hard to imagine this. It couldn't even have had space around it, because all the space was packed in there too. Then something dramatic happened. This infinitely small thing exploded. The infinitely small point started to expand outward. It was like a tiny, fiery cloud. The whole universe was in that cloud. Or maybe we could say the seeds of the universe, or the potential of the universe was in there. The particles of it were moving outward from the starting point, propelled by a great force. The heat so intense that all the substances we know, iron, gold, earth, rocks, water, they all existed as gases, as insubstantial as air. Imagine, all these substances, all the materials that the earth and the stars are composed of, were fused together in one growing, flaming intensity of light and heat. It would make our sun today feel like just kind of a warm day in the sunshine in comparison. As this cloud of light and heat expanded, some of the particles began to collect. If you swing the water out of a glass, it breaks up into separate little drops. The stars are like these little drops, only instead of falling, they're constantly being flung away from their starting point, in such a way that they can never meet. They are millions of miles from each other. Indeed, some stars are so far from us, it takes millions of years for their light to even reach us. Do you know how fast light travels? It travels 300,000 kilometers per hour. 300,000 kilometers per second. Imagine how fast that is. It means that in 1 second, it can travel 7 times around the whole world. And do you know how big the world is? If we try to drive 80 kilometers per hour non-stop all day long and all night long without stopping, it would take us more than 20 days to cover that distance. And yet the light covers it 7 times in 1 second. You can say 7 times. Go ahead and try it. Say 7 times. Well, it's just gone around the Earth 7 times already. So, can you imagine how far away some of these stars are? That it takes their light 1,000,000 years to reach us? There are so many stars that scientists have calculated that each of them were a grain of sand. All the stars together would cover up most of Europe to the height of 200 meters. One of these stars, one of these grains of sand among those thousands of billions of grains of sand, is our sun. And a tiny bit, a speck, just 1/1,000,000th of this grain of sand is our Earth. A speck. The sun doesn't look so big, but that's because it's so far away. The light from it takes about 8 minutes to reach us, and if we were to travel the same distance at 80 kilometers per hour, it would take us a little more than 212 years to reach the sun. In fact, the sun is close to 1,000,000 times bigger than the Earth. So far as we know, at the time of that explosion, and to this very day, every speck which we might think too tiny to matter follows a set of rules. The little particles in that explosion were so hot, they were like smoke, like vapor, and because of the force of the explosion, they were moving away from the point where the explosion started. And they were moving at a fantastic speed, and right away they started to follow a rule that said as you cool down, you must slow down, come together in groups, and become smaller. And so, as they cooled, they moved more and more slowly, and many of them clung closer and closer to each other and took up less and less space. The particles assumed different states, which now we call the solid, the liquid, and gaseous states. Everything we know is either a gas, a liquid, or a solid, and which of these 3 states it is at the moment depends on how hot or cold it is. Each of the little tiny particles somehow developed a special love for certain particles and a special dislike for others. Some were attracted to each other, and some were not. Based on this attraction, they formed themselves into different groups. In the solid state, the particles cling so closely together, they're almost impossible to separate. They form a body that will not alter its shape unless you apply a lot of force. If a piece is broken off, the particles still cling together. If, for instance, you start chipping a stone, the remaining main part of the stone and the chips, well, they all remain solid pieces of stone. Here, take a look at this. I'm going to break this stone here and watch what happens. Now, pretty cool, huh? When it comes to liquids, the rules seem to say you shall hold together also, but not so very closely so that you will have no shape of your own and will roll over each other. The rule seems to be you will flow and spread, filling every hollow, every crevice in your path. You'll push downwards, sideways, but never upwards. Liquid's flexibility in this way is why, though we can put our hands in water, we cannot put them inside a rock. And the gases somehow developed a rule that said our particles will cling together they won't cling together very much at all. They can move freely in all directions. But the particles did not become solid or liquid or gas at the same time. At a certain temperature, some remained solid, some became liquid, and still others became gaseous. And so, while obeying these laws, the little drop that was to become our world went spinning and spinning around itself and around the sun in the tremendous cold of space. As time went on, the outer ring of this mass became a dance, the dance of the elements. The particles that were at the outermost edge became cold and shrank. Huddling together, they hurried to the earth. But as soon as they approached the hotter part, they became hot, and up they went again. It was like they carried a bucket of hot burning coal into space and returned with some ice. How marvelous it is! How simple! If you become hot, you expand, and as you expand, you become lighter, and soar upwards like a bubble of air in the water. But if you become cold, you shrink and fall as a grain of sand sinks to the bottom of a pond. Well, because of this law, the earth gradually changed from a ball of fire to the earth we know now. This was the law that the tiny particles obeyed as they danced their dance. Tiny particles that were too minute to be seen, yet numerous enough to make up our world. For hundreds, thousands, millions of years, this dance went on. Finally, the particles settled down like tired dancers, and one after the other they became first liquid, then solid. As they became liquid or solid, some of them joined others to which they were attracted, forming new substances. The heavier ones went near to the center of the earth. The lighter ones floated above them, like oil floating on the water. Now, a thin scum was formed, like the skin which forms on milk when it's boiled and left to cool. It seemed as though the earth had taken some shape, but the elements inside the skin were still really hot. It was almost like they felt trapped. They wanted to get out. What could they do? They had to follow the law. If you're hot, you expand. But there was no place to expand, and so they burst out. They broke the skin of earth. It was like a terrible fight, an explosion. The water that formed on the surface turned immediately into vapor and went up as the hot stuff came out of inside that earth. There were also ashes. A veil of clouds covered the earth so nobody could have seen what was going on. Eventually the fighting ceased as everybody cooled down. More and more gases became liquid, more and more liquids became solid. The earth itself shrank and became wrinkled like an old apple left in a cupboard. The wrinkles are mountains, the hollows are the oceans. For as the rocks cooled down, water was able to return to the earth. And it rained, and the water, being liquid, filled every hollow and crevice found in its path. And so the oceans were formed. Above them was the air that we breathe. The cloud would break up, sometimes disappear altogether, and reappear again. Well, it was like a veil had been withdrawn, and the sun could once again smile upon its beautiful satellite, the earth. Rocks, water, air, solids, liquids, gases. Today, as it was yesterday, and as it was millions of years ago, natural laws are obeyed in the same way. The world spins round itself and round the sun, and today, as millions of years ago, all the particles that make up our planet Earth, seem to be working to fulfill their tasks, and as they do, they seem to whisper with one voice, "We will obey."